problem are we actually trying to solve? Today's question is, are we solving the wrong problem when we talk about data centers and how much water data centers use? Because the numbers, we see millions, billions of gallons of water, large numbers, immediate and concerning, especially in places where water is scarce. So before we react to the numbers, it's worth asking a more fundamental question. What's the number actually measuring? Is it measuring water used at the data center by the data center? Or is it combining multiple water usages from other places like energy that's produced, electricity, the manufacturing of the actual servers and the technology inside the data center? Is that all figured into this single figure? Because if it is, that changes how we interpret who's responsible and how big it is. Because the way a problem is framed determines the solutions we might come up with. If we're measuring the wrong thing or combining variables and numbers from different sources that really don't belong together, we'll end up solving what might seem visible or casual, but not the real problem. So in this piece, I'm not arguing for or against data centers. This is about asking, are we thinking about a problem correctly? Water use, especially where it's scarce, it's an emotional topic, and rightly so. When a topic becomes widely discussed, the way the numbers are presented matters. Large figures can create an impression when they combine numbers from different systems, and you can care deeply about an issue, and still, it's okay to question, how's it being measured? Because it helps us solve the problem better, the right problem. Okay, so what data centers actually do and don't do? It sounds simple, data center, and it seems like, okay, that's a place where data is stored. But that's not the complete model. A data center is actually a place that stores, processes, and moves data, meaning not just your pictures, your files, your backups. Got compute, processing, application, software, transactions, AI, any website, application, transaction, and then, of course, movement, downloading, uploading applications. What it doesn't do, a data center doesn't drive all this, it responds to it. So it doesn't get to decide what data gets created, stored, deleted, or replicated. And it also doesn't control how efficiently software is written, because developers can write better code that executes smoother and faster. It doesn't control that. It doesn't control the decisions on software design. It also doesn't control where electrical power comes from and how power is generated. Those decisions are made somewhere else by users, product designers, business models, and our energy system. So the claim data centers are using massive amounts of water, you hear numbers like 5 million gallons per day, or it's equivalent to a town of 10,000 to 50,000 people. Sounds staggering. Or a statement like, AI will increase our water usage by 870%. What's actually being measured? So first, what does, quote, water use by a data center mean? It's blurred from different sources, I say ironically, because there's always good intentions. Researchers trying to understand the larger footprint, they've combined numbers from 3 different sources, and most people aren't aware of that when they hear the number. First is the water withdrawal. Now that sounds straightforward. Water's taken and later returned. Water consumption, water's not returned due to evaporation. What's often invisible is the discharge, meaning water is often returned. It's ignored in the number, meaning it doesn't evaporate. It is returned to, cleaned up and returned. What the largest number is measuring, the number, attributed to a data center. It's not measuring what happens at the data center itself. It's measuring water used to generate the electricity the building consumes, as well as the water used by the cooling towers and water used in the manufacturing of the silicon chips and the actual servers. A data center cooling system is one water system. This is what turned me on to the whole questioning the number as soon as I heard it, because they're pointing at cooling towers. And as an engineer, I'm like, man, it's fascinating how efficient cooling towers are, better than actually using electricity to run the air conditioner, which hogs a tremendous amount of power. A cooling tower is a way power generation stations and large commercial buildings and even campuses like universities that generate their own power and their own cooling will use cooling towers and chilled water because it's much more efficient and cheaper than trying to use electricity to power air conditioning. But they put these together. So when they're combined into a single number, they make the impression that the visible data center is responsible for it all. The number being used no longer describes the building. It describes pretty much the electricity behind it. So that changes the question from how do we reduce water usage at the data center to how is electricity generated? How much water is required to cool systems that generate electricity? Is there a way to do it without using water? And how much electricity does a data center actually demand? Because your next thought might be, well, it doesn't matter because data centers use a lot of electricity still. It's a no-brainer, right? On quick thought, seems logical, but let's actually look at some numbers. But first, where the water's used. It's called a data center water footprint, single number. Data centers draw electricity from the grid. Some think data centers have their own power source. Sometimes they do. But mostly power is not generated on site. And you hear this a lot in a lot of businesses like to say this, we're eco, we're green. What's carbon neutral is a term. They still literally do not have only solar panels on their roof. They're pulling from the grid. Even if they say, I want my electricity, tell the power company, you know what? I want my power to come from solar. It's all mixed up together. Difference between is the power center actually at the data center and not. Semiconductor manufacturing, by the way, because this one really tricked me. I'm like, really, who would do that? Combine? It's researchers again. It's taken out of context. This is a research number just to study what theoretically might be the total water footprint of a data center. It's not actual on-site, literally, like at your home, what's my water bill, how many gallons I used. Semiconductor, the hardware. How much water does it take to make chips? And all systems use water someplace in their life cycle. Some systems use it continuously to manage heat, and others maybe during manufacturing. A system that uses water once is not the same as using it all the time, and that again is combined in the number. Cooling towers are often misunderstood. They're closed loops, meaning like a swamp cooler in a dry climate. Way cheaper than running air conditioning and actually get things colder. They're closed loop. They reuse the water. Yes, some is by evaporation. That's not the same thing as continuously extracting new water from the ground continuously. And using a cooling tower and a chiller inside a building is similar. Are the data centers unusual in terms of a large building? Offices, hospitals, universities, they use similar equipment. And per unit of heat removed, these are efficient systems. The difference is the load. The data centers are going all the time, and they probably generate more heat than having a couple people in an office with a few computers, and they require constantly cooling. It doesn't use more water because it's a data center. It uses it more because the building's always on. But is it even using that much water? Not the way implied. It depends on electricity, but that water is used for electricity generated someplace else. So they're attributing these water usages that actually are occurring at other places. A table I came up with, and you can come up with your own. I'm going to round the numbers off, and you're probably going to come up with some different numbers, so my numbers are spread. For example, if you take the 100% being the number that data centers are reported to use, 60 to 80% comes from power generated off-site. Only 20 to 40% actually comes from the cooling tower itself. And in chip manufacturing, it's probably 10% at tops. Sometimes you'll hear statements like, oh, if you query one AI query, ask AI one question, it uses X amount of water, as if that is a precise number. That's an impossible number to get because you don't know how many queries are going to be made in the future. They describe an average based on a continuing operating system. It's going to change. The data center doesn't turn on and off per request automatically. It has a baseline. It's always emitting so much heat and needing so much cooling. Individual queries kind of incremental loads. It's like saying, I drive my car so many miles, as if you can use a fixed amount of fuel to do that, without knowing that your engine might be idling part of the time. Or a better one is the heat in your radiator. Your car idling is emitting so much heat, even if you don't drive it. But then when you start driving, it actually cools down a little bit because your cooling system kicks in a little bit, starts to cool it off. Now it's actually kind of managing the heat better. And you could go as fast as you can in that car. Once that cooling system is designed for a certain load, it's quite efficient. It really doesn't matter if you drive faster, maybe harder uphill, but still you're going to have some cooling and heat generated either way. It's not as if it's linear and at some point it breaks unless the system breaks. So what the numbers are often measuring is not the data centers. They're measuring electricity. Most of that water is attributed to power generation. Data centers may feel big. They're actually, here's another interesting part, because we hear the water usage, it's equivalent to a town of 50,000 people. So you think the electricity equivalent to a town of 50,000 people. No, it's actually a small slice of total electricity use. More or less, data centers use approximately, let's say, 5%. It could be, some figures say lower. I'm going to pick the highest one, 5% of the total U.S. electricity. That means 95% of electricity and the water usage is somewhere else. Power for your home, industry, transportation. Basically, the data centers are a small percent of the actual power. Now let's pretend, what if electricity were unlimited? Because the water constraint really relates to electricity being generated. What if just electricity were unlimited, so abundant and not water intensive to produce? How's the picture change? Well, data centers would still use the water for cooling, as I explained. Kind of like a swamp cooler instead of air conditioning. Not any different than a large building. Campuses, universities, hospitals, they have their own cooling system. So it's not a data center question, it's a system-wide question about how we generate electricity, how much we consume, and what we choose to do, what we choose to allocate electricity for. So focusing on data centers isolates that one visible node, the cooling towers. So focusing on the data center really doesn't explain everything else in the system that we live in. The deeper concern is not the usage, it's the allocation. Back to water. We need it for drinking. We need it for basic human needs, agriculture. I met a rancher who was concerned because running out of groundwater, they need it for cattle. The real question becomes, is a data center competing with those needs? The answer depends on the source. If water is used for a cooling tower or power generation comes from non-potable sources, if the water is recycled that the data center is using, if it's not part of the municipal water system, then that changes. Not all water used at these places is drawn from the same source. When all the water use is combined into a single number, it creates the impression that data centers are taking water directly from the same place used for essential human needs. Not always the case. I understand we have droughts and wildfires and whatnot, and water is a big issue. That is an issue. We'll stick to the data centers, where they get water from, what they use it. Because without separating the source and the system and the location, the conclusion becomes easy to become incomplete. Why the story focuses on the water? I think it's because electricity is expected and it's abstract. Try to picture electricity being generated. Water is more tangible and local. You can see the hot, dry conditions. You can see the drought. You can look at your water bill. You can be warned that we're in a phase 2 or 3 drought and you can't wash your car, else you'll be ticketed. You don't see that with electricity. A megawatt might not mean a lot. Millions or billions of gallons of water, it kind of gets understood better. And research on this issue began with the system level estimates. They simplified everything into single numbers, and that number got attached to the most visible part of the system. The driver is electricity. The story is being told through water. We're focusing on the visible variable, the one that's easy to see, not what's actually perhaps causing the problem. So my final thought on this is it's not about data centers. It's about what happens when a large number is presented without context. Multiple parts of a problem are collapsed, combined into a single variable, and solutions target what's visible. When I first learned that data centers, when I first heard data centers use large amounts of water, I pictured them pumping water out of the ground nonstop. And then I thought, well, tried to picture it being evaporated as fast, and that didn't make sense because cooling towers are efficient. It would be a no-brainer. No engineer would design something like that would fail as soon as the pump stopped pumping water. And so I just started asking the questions, and the mismatch led me to ask a different question. What's actually being measured? Data centers use water. Much of the water attributed to them comes from how electricity is generated, not from what is used at the facility, and again, not from electricity either generated at the system. This raises another question. If it were in fact true, if what I've been saying is actually not completely correct and water is actually the constraint, let's pretend, what are some ways to generate power? Because it still comes back to power. It's not they're pumping groundwater out of the ground, the data centers, to use for cooling, literally. They're using it for power generation. So the question is, can you generate power that doesn't need water to cool its power generating system? And if those options are limited, meaning not in practicality, is the real constraint the water or the electricity? The question isn't whether data centers use water. The question is whether we understand what's driving that use. Because most debates about data centers and water, they're not about water. The number is real. It doesn't represent what most people think it does. The number combines water from multiple systems, power, cooling, and manufacturing, and assigns it to a data center itself. I forgot to mention the statistic, or it's just a ballpark here. I worked in semiconductor manufacturing, and you don't really go online and see how much water you used. Some of the numbers you give to the city, well, as an engineer, I can tell you also that's estimated. But more or less, a large data center, let's say it uses a few million gallons per day for cooling. A manufacturing facility can use several million to tens of millions per day. They're either similar or the manufacturing is actually using more. When we get to the manufacturing part of it, I don't know why they even include that in the number. Again, I think these were research projects that use these numbers. If you can come up with, tell me what seems like the reason can point to how this got started, the numbers combined, I'm sure there's good intention behind it. The numbers isn't exactly real the way people think it is. It's an aggregate number, doesn't really describe what's happening at the data center. Question is what the number is measuring and whether that's the real problem we should be solving. Solve the right problem. If we misattribute where water is used, we risk solving the wrong problem, the wrong part of the system. Thanks for listening. Till next time, I'm Daniel Stee.